Good day, my name is Christopher Heredia and I'm from the University of Belize, and today I'll be discussing the topics I learned in my Building and Services course. Here are the topics: cold water supply system, hot water supply system, electrical system, fire prevention and control system, building ventilation system, and air conditioning systems. Start off by cold water supply system. Infrastructure for the collection, submission, treatment, storage, and distribution of water for homes, commercial establishment, industry, and irrigation, as well as for public needs as firefighting and street flushing. People depend on water for drinking, cooking, washing, carrying away waste, and other domestic needs. Water supply system must also meet requirements for public, commercial, and industrial activities. In all cases, the water must fulfill both quality and quantity requirements. Due to of our municipal service, provision of pot water is perhaps the most vital. In a water supply system, there are many things to consider, such as the type of water source, which water will be extracted from, such as shallow wells, deep wells, artesian wells, and springs. From these sources, in order for the water to be potable, it must be filtered first, and there are many ways in which a body of water can be filtered. Here are a few examples of how water can be filtered: slow sun filtered, pressure filtered, domestic filtered. In a home, water can be distributed using different system, a direct system or an indirect system. Although hotels and motels and apartments like to use indirect system due to its main supply source is cut off, there is a backup storage in place called the cistern, which stores water for redistribution in the indirect system. Moving on to hot water supply system. In hot water supply system, a source of hot water for residences and public and industrial enterprising to surprise a domestic and production needs. Also, the complex of equipment and structures that provide it. Water supply system consists of heat sources, water treatment apparatus, water heaters, pipelines to transport the water, and devices to regulate and control the water temperatures. The water provided by hot water supplies in resident and public buildings and in industrial enterprises for their operational daily needs must be potable, and this can be distributed by direct fired water heaters, which are solely dedicated to the job of hot water generation, provided a faster heat up and response time compared with an indirect system, which is in fact heating water to heat water, or by a direct water supply, which works because only thing they do in generate hot water. This makes them more efficient than indirect hot water supply. It works faster, means it is less likely that people will have to wait for hot water to take showers. There are many safety devices in place to regulate hot water temperatures, such as stem thermostat, bulb thermostat, electronic thermostat, and smart thermostat. Moving on to electrical systems. An electrical system with the context of a building is a network of conductors and equipment designed to carry, distribute, and convert electrical power supply from the point of delivery or generation to the various loads around the building that consume the electrical energy. Electrical system. In the most simple form, an electrical circuit consists of three fundamental parts: a power source to drive electrical current around the circuit, which is a battery, a conductor to carry the current around the circuit, some cables, and a load that resists, a bulb, a heating element, or a motor. In electrical power distribution, a service job is an overhead electrical line running from the utility pole to a consumer's building or other premises. It is the point where electric utilities provide power to their customers. The service entrance, as the name implies, is where the wires connect to the load side of the meter entering the house or building. The service entrance is in a residential home is as of the breaker or a fuse box. Grounding gives electricity the most effective way to return to the ground via the electrical panel. A grounding wire gives an appliance or electrical device a safe way to discharge excess electricity, and an electrical circuit relies on both positive and negative electricity. Here is a video that gives an analogy of how a circuit works.
A closed circulating water system offers a simple analogy for illustrating the way an electrical circuit works. The top diagram represents a water system, while the bottom diagram shows a simple electrical system. In a water system, a pump creates a pressure difference which forces water through a pipe and other hydraulic components. In an electrical system, a battery or a generator creates a potential difference or voltage that can force electric charge through a wire as well as through electrical components. The electrical system shown here illustrates the operation of direct current, which flows in only one direction. While many electrical systems operate on alternating current, a direct current system is easier to visualize. In a circulating water system, the water flows in a loop and returns to the pump where it is again forced through the loop. A shutoff valve can stop the flow of water when closed, or allow it to flow when in the open position. An electrical system is also a closed system. Electric current must flow in a loop or a completed circuit. Instead of a shutoff valve, a switch stops the flow of current through the circuit when it's turned off. When the switch is turned on, the circuit is completed and the current flows. In this water system, there is a hydraulic load, in this case, a water turbine, that is powered by the flow of water. Our electrical system also has a load, an electrical load represented here by a light bulb. The light bulb is powered by the electrical current. As mentioned earlier, the pump in a water system creates a pressure differential that forces the water through the pipes. Therefore, our diagram includes two pressure gauges to measure the difference in pressure. The electrical system relies on a voltmeter to measure the potential difference between 2 points in a circuit. As water flows through the system, the flow rate can be measured in gallons per minute or liters per minute and is measured with a flow meter. Electric current flowing through a circuit is measured in amperes or amps and can be measured with an ammeter. The analogy between water systems and electrical circuits can be taken further, but we'll stop our comparison here for now. An electrical circuit is more typically depicted in schematic form. In this schematic, the voltage source is depicted as the circle on the far left. The electrical load is generally depicted as a jagged line. While it's not necessary to know how to draw an electrical schematic, this fundamental understanding will be useful.
Moving on to fire protection and prevention. Fire prevention system. This process happens before the fire even ignites. One of the most effective tools for fire prevention is an inspection. Regular property inspection can be used to identify vulnerable areas in your facility and once identified to fix them. These vulnerable areas can be things like overloaded electrical outlets, improper maintained system, and improperly stored materials. Fire protection systems is a combination of different fire safety equipments and procedures that are used to defend your property line from fire. Fire protection often includes equipment like fire alarms, extinguishers, and sprinkler system. Together, these systems work to ensure your property is constantly protected. The classes of fire includes Class A for combustible wood, paper, cloth, plastics. Class B for flammable liquids such as petrol, oil, and lacquer. Class C for electrical fires, which is electrical equipment. Class D for flammable metals such as lithium, magnesium, and titanium. And Class K for wet chemicals such as vegetable fats, which is found in oil and grease. There are many devices set in places, such as smoke detectors, fire extinguishers, sprinklers, and alarm. Ventilation in a building. Ventilation moves outdoor air into a building or a room and distributes the air within the building or a room. The general purpose of ventilation in the building is to provide healthy air for breathing by both diluting the pollutants originating in the building and removing the pollutants from it. Here's a video explaining ventilation.
The ventilation unit with heat recovery is placed in the attic. The unit is connected to two air collectors, one for fresh, cool outside air and another for warm, dirty indoor air. Through the red line, dirty air is removed, whilst through the blue line, fresh air is channeled inside. The blue spheres represent fresh air and the white spheres pollutants such as pollen. Fresh air is first purified through a filter. The red, warm and polluted indoor air is then extracted and removed through the bathroom and kitchen. In the ventilation unit, the two air streams cross but never mix. Because of the proximity of the airflows, the cold air becomes warmer and the warm is cooled down. The warmed fresh air goes through a silencer to the distributing air collectors. Each conduit is connected to air valves, which distribute the fresh air to the bedroom and living areas. The fresh air is blown in the bedroom. In large areas, more valves are fitted to distribute the air equally. Through vents, airflow between different spaces is made possible. The polluted indoor air is extracted through the bathroom, toilet or kitchen. First, the dirty air is transferred through the air collector to the ventilation unit, where the heat is then extracted from the air. The air is then blown outside. This ensures that in the bathroom, for example, no condensation can be found, and in the kitchen, no cooking smells remain. Thanks to the ventilation system, the correct amount of air arrives at the right place.